Hello, today I'm gonna share my thoughts on um, the operational data versus decision support data. I think it's kind of some old concepts. It may be outdated. It's more like the OLAP system versus transactional system, the data in OLAP system versus data in OLTP systems. So what's the difference between decision support data and operational data? Um, the operational data, or I would call it like data in OLTP systems, they are more likely to be divided into multiple tables. Um, for example, a simple sales transaction might be represented by 5 or more different tables such as invoice, invoice lines, discount, store, and department. Although like these arrangements may be excellent in operational systems, but it's not efficient in analysis systems. If you want to extract a single invoice, you would have to do multiple joins, like join at least 5 tables to get one simple invoice. Although like operational data is useful for like capture daily transactions, the decision support data it's more likely to give tactical and strategic business meaning. There are 3 specialties of operational data: the time span, granularity, and dimensionality. The time span is that for a business manager, you may want to know like what's the sale of the last 3 months, the last 1 year, or the last 5 years. We want to see the time span of a decision support data. The second specialty is granularity. That's more. It's also an easy to understand concept. That we may want as a business manager, we want to know like want to know the sales by region or by city within a region, or by store within the city within the region, and so on. In that case, it's like when we want to drill down or decompose our business data, or in the opposite way, when we want to roll up the data, when we want to aggregate the data at a higher level. And the last characteristic of the decision support data is that the decision support data has dimensionality. It's that we instead of we want to see individual transaction, for decision support data, we do not want individual transactions. Instead, we tend to include more data dimensions, and we are interested in how data relates over these dimensions. For example, we may want to know how product X fared relative to product Z during the past 6 months by region, state, city, store, and customer. In that case, both place and time are part of the picture and all that. So further, like they are part, both place and time are part of our dimensionality. Dimensionality. So like uh, I mean that we have like normalized rules. I forgot we have no normalized rules for RDBMS, like the normal, the first normal rule, the second normal rule. To this help us to divide one single data into multiple tables and to store it in a RDBMS, so that we can keep it easy for us to do update and make it as more easy to be consistent as possible. But for like the decision support data, to help us to aggregate, we may want to store a lot of data in one table, but this data may be duplicated partially. Maybe they may be kind of duplicated and normalized. For example, if in a region there are like 20 stores and each of the stores has 2 departments, and each of the department has their own sales, and also we collect these stores sales in a time span of 10 years. Each year has their own sales. Like their data may be like the year 2000. In a single year, we have 20 department and 20 sales, but we have only 2 stores. Like these data are kind of duplicated to a certain degree, and we may want to store them in one single table to make it easy for us to do aggregates. So these schema are optimized for read-only query retrievals, and we may want to support this DBMS must support features such as bitmap index and data partitioning. That's one requirement for the like decision support database. And also the decision support database is another requirement for the decision support database is that the decision support database must support data extraction and filtering in an efficient way. The decision support database must import data from operational database and import additional data from external sources, so that thus the DBMS must support advanced data extraction and data filtering tools. the data extraction of the DBMS should allow batch extraction and scheduled data extraction, and for the data filtering capabilities, they must include the data filtering capabilities must include the ability to check consistent data or data validation rules. Like the data may be, for example, the date may have a lot of formats. You can have backslash separated dates, or like dash separated dates, or somebody may even just input 8 digits of numbers to represent a date. You must check and convert them into one common format, so that it would be easy for us to do further analysis. So that we can do further analysis. Last but not least, the requirement of decision support this database is that this database tend to be very large, like gigabytes or terabytes, are not unusual for the decision support database. So Walmart has more than 4 petabytes of data. So the DBS must be able to support very large databases. Even more importantly, they must be able to support like multiple processor technologies. Yeah, these requirements makes like sophisticated data analysis to evolve into a new field of research. It has become the foundation of a new generation of decision supporting system, and it's called the data warehouse.